ಎಲ್ರಿಗೂ ನಮಸ್ಕಾರ. So today's topic is total internal reflection. It is one of the important topics from the chapter Optics and Optical Instruments again. So there is one more important topic in this particular topic, that is critical angle. So here let's say this is the surface and here is the normal. Normal is always perpendicular to the surface. Let's say this is denser medium and this is rarer medium. So in total internal reflection, the light ray travels from denser medium to rarer medium. So this is the incident light. Okay, so this is the incident light. If there is nothing, this incident light would have gone in this path, right? So since there is one more medium, it gets refracted in the other medium. So when the light ray travels from denser to rarer medium, the refracted ray, it moves away from the normal, right? So incident ಆಗಿರುವಂತ ಎಲ್ಲಾ rays, will they get refracted? No. Some of the rays, they get reflected as well. Okay, so this phenomena is called as internal reflection, right? So here the incident rays, they not only get refracted, they also get reflected. So not all the incident light gets refracted. Some of the rays, they get reflected as well. So we call this phenomena as internal reflection. So now what happens if I further increase the angle of incidence? So we know this is the angle of incidence, this is the angle of refraction now, and this is the angle of reflection, right? What if I increase the angle of incidence? So here I'm increasing the angle of incidence. So I'll increase the angle of incidence. So here is the reflected ray, and this refracted ray, it further moves away from the normal. It further moves away from the normal, right? So here is the angle of incidence, angle of reflection, and this is the angle of refraction, right? It further moves away from the normal. So at one point, what happens? You are increasing the angle of incidence, and this refracted ray, it overlaps with the surface. Okay, so when it overlaps with the surface, it makes angle 90 degree with the normal. The refracted ray makes an angle 90 degree with the normal. So here basically, at what angle of incidence the refracted ray is giving us 90 degree, that angle of incidence is called as critical angle. So this is basically critical angle. Critical angle is that angle where the angle of refraction is 90 degree. When the angle of refraction is 90 degree, the angle of incidence is called as critical angle. So now if you further increase the angle of incidence, what does that mean? That means if you increase the angle of incidence greater than critical angle, if the angle of incidence is greater than critical angle, then there will be total internal reflection. Why? Because the refracted ray, it further moves away from the normal. That means it comes in the same medium. It comes in the same medium and it acts like reflected ray, right? So I'll consider the same thing. Here we'll see the diagram. Here is the normal. We'll further increase the angle of incidence. Let's say this is critical angle and I'm further increasing the angle of incidence. So this is the angle of incidence. Okay, here angle of incidence is greater than critical angle. Okay, here at this condition, what happens? The refracted ray, which was overlapping here, it comes in the same medium and it overlaps with the reflected rays. So here what happens? Now this is the angle of incidence and this is the angle of reflection. As you can notice, I'll rub this up. This is the angle of incidence and this is the angle of reflection. As you can notice here, the rays, the light rays which are incidenting all the light rays are reflecting in the same medium. Here only some of the rays were reflecting, so we called it as internal reflection. Here when the refracted ray gave us 90 degree, the angle of incidence is called as critical angle. Now if you increase the angle of incidence greater than critical angle, you will have the refracted ray in the same medium. So here all the incident light gets reflected now. So you call it as total internal reflection. Why is it total internal reflection? Because all the incident lights are reflected now. So this phenomena is total internal reflection. In total internal reflection, there are 2 points. First point, the light ray should travel from denser medium to rarer medium. It should travel from denser to rarer medium. Second is the angle of incidence must be greater than critical angle. The angle of incidence must be greater than critical angle. So these are the 2 points which you need to write whenever they ask you about total internal reflection. So they'll ask either the definition of total internal reflection. When they ask you definition, you have to write these 2 points. Or they will ask you the conditions of total internal reflection. Then also you need to write 2 points. These are the 2 points. So this is about total internal reflection. So I hope you have understood. So let's meet in the next video. Thank you.